Hey, fellow mathers, the wait is over. Register today for your Building Powerful Mathematics workshop.
Y'all, registration is only open 3 times a year and you don't want to miss out.
Visit mathisfigureoutable.com/action to select your choice of workshop. You'll gain access to world-class professional development that will help you make a lasting impact in your students' lives.
You can save your spot at www.mathisfigureoutable.com/action. We'll see you on the inside.
Hey, fellow mathers, welcome to the podcast where math is figure-outable. I'm Pam Harris, a former mimicker turned mather.
And I'm Kim Montague, a reasoner who now knows how to share her thinking with others. At Math is Figureoutable, we are on a mission to improve math teaching.
We know that algorithms are amazing human achievements, but they are not good teaching tools because mimicking step-by-step procedures can actually trap students into using less sophisticated reasoning than the problems are intended to develop. Hello?
I have to tell you in a second what I just thought about. In this podcast, we help you teach mathing, building relationships with your students, and grappling with mathematical relationships.
We invite you to join us to make math more figure-outable and to figure out what Kim is thinking in her head when
For whatever reason, when you just said trap students, I totally pictured like a little mouse trap, like a piece of cheese and a little mouse. That's horrible. But I don't want to trap students.
We don't.
It's
we
bad.
Do not,
it's bad like that.
We do not want to trap students. That is
gosh.
correct. That is the main point of all the things.
Listen, we might have to get a different intro because I kind of gloss over a little bit. I try to pay really hard. I try to pay attention. Like I'm a focused person, but sometimes
said it too many times.
Yeah. Hey, last week we talked about integer multiplication. Yay! People have been asking about that.
So, yeah, been asking for a long time.
I know.
Yeah. Hope you liked it. Good.
Okay.
Good.
So this week let's tackle integer division.
Integer division.
Mm-hmm.
Bam. All right. First thing, if you have not, please go listen to last week's episode because it's going to be super important that you kind of heard how we laid the groundwork for integer multiplication. A thing to know is I don't know that I would immediately move into integer division, though I could, but I would acknowledge that I'm not done with integer multiplication. I would do more integer multiplication strings, kind of like we did with different facts, different numbers. I would, as you do that, try to keep the feeling tone less, oh my gosh, you guys are supposed to know these facts, and more, all right, we're getting good practice with these facts.
That's never helpful. You should know this.
Yeah.
That's not helpful.
Yeah. But hey, look, we're getting good practice with these facts. That's a good, maybe a more helpful way to approach all the things. Okay. So with integer division, it's all about getting better at two things: division and opposite. And when I say opposite, I mean looking at a negative and being able to think of opposite in a few ways. Being able to think of a number line where if 9 is over here, then -9 is its opposite, which means I'm going to reflect it over 0. It's the same distance over 0. So I want to use the word reflection. I want to use the word opposite. And it's also being able to think about the opposite of a product.
Mm-hmm.
So what does that mean? It means that when I think opposite, I see a negative sign. And when I see a negative sign, I think opposite. And when I see both of those, think about both of those, I see this reflection across 0. Mm-hmm. So kind of all of that stuff kind of intertwined. All right. So when I say it's about those two things, getting better at division and opposite, that also means that there's some division work that could be helpful here. And so ideally we would have done some whole number division work. So the kids are actually thinking about the two meanings of division and they have some strategies for division. Mm-hmm. I would much rather have kids take a little bit longer to use a strategy to figure out a division than for them to have a fact rote memorized and spit it out and then not be able to have relationships for me to use in further math.
Right.
Okay, so let's do a problem string
for
integer division. Here we go. All right, Kim. 36 divided by 9. What you got?
4.
And how do you think about that? I mean, that's probably a fact but like...
there are 4 9s in 36.
Okay, so you're thinking about that pretty quotatively. And if students are not, meaning how many of these are in those. If students are not, then I'm going to nudge that. So I might say, hey, another way of saying this problem is how many nines are in 36? And kids are like, okay, 4. So I'll just have that. Up till now, I don't really have a whole lot else going on. I've got 36 divided by 9 equals 4.
Mm-hmm.
Let me actually just think for a second. I'm thinking. There is a world where I might have represented that on an open number line where I've got 0
Mm-hmm.
and I put 36 over to the right. And I say,
Mm-hmm.
so you're telling me there are 4 nines in 36. How many nines are in that 36? 4 of them. And I might have just quickly drawn 4 jumps.
Mm-hmm.
Maybe put nines above them. I don't
Mm-hmm.
know that I would do that. I don't think I would do the interim landing points.
Mm-hmm.
So you're telling me there's 4 nines in that 36. Okay, cool. What if I ask negative 36 divided by negative 9 and I use the same interpretation? How
Mm-hmm.
many negative nines are in negative 36?
Mm-hmm. Still 4.
And so I might go up on that same number line and I might go, where is negative 36, y'all? And I want students to say, well, it's got to be the opposite. So it's reflected over the number line. It's going to be the same distance from 0 over there in the negative land. I could have been doing this on a vertical number line. I think I would probably do the first problem on a vertical number line, maybe the second one on a second set of problems on a vertical one. So I'm on a horizontal one right now. So you said also 4. So I would say you're telling me that if I jump back these 4 nines, there's 4 jumps of 9 in this negative 36, but I'm jumping backwards, so those are jumps of negative 9.
Mm-hmm.
So how many negative 9s are in 36? You're saying also 4. And then I'm going to sit. I'm going to do what Anne Roman, a colleague who I have not talked to for it could be 20 years, maybe 15 years. And I called her up the other day. I'm going to quote her in one of my books. And one of the things that she told me once is she's a horsewoman. She trains horses. And she said, when you train a horse and you have done something and you've asked them to do something and they've done it correctly, then you just sit there and you let it soak. This is a moment where I've got on the board 2 problems and I've got a number line, 4 jumps of 9 to the right, landing on 36, 4 jumps of negative 9 to the left, landing on negative 36. These 2 problems, and I'm just going to sit. And I'm going to go, what do you guys see? What are you thinking about right now? Now, Kim, I don't know what you're thinking. I don't know. I'm not sure if you're thinking about what, and I don't know that I'm even going to get anything like really new or
Mm-hmm.
fantastic from kids, but I think this is a moment to soak. So just like,
It's you soaking gives it a little bit of weight. It gives a little bit that like there's something here to consider,
worth
which I think is
considering.
good. Yeah.
Yeah. And I would hope that some kid would say, well, I'm definitely seeing 36 over there. I'm seeing negative 36, the opposite. I'm seeing these jumps over there, but those are jumps to the right. So they're positive. These are jumps to the left. So they're negative. And I can see 4 of those jumps of negative 9. Sure
Yeah.
enough.
Either way, it's 4 jumps. Uh-huh.
Yeah. Notice, again, kind of like you said in the last episode, there's no rule that I'm putting out here. I'm asking kids to reason how many negative 9s are there in negative 36. Cool. So then I might ask the question, next question, negative 36 divided by 9. I'm going to pause. Kim, what are you thinking about?
I'm thinking about 30.
Oh, can I back up?
Sure.
When we were still on negative 36 divided by negative 9, a teacher move that I think I would have made is I might have said, did anybody use opposite to think about this problem? Did anybody think about 36 divided by 9 and then use opposite like we've just been doing in multiplication? If I ask that, Kim, does that make any sense to you?
Yeah. If you're thinking about 36 divided by 9 is 4,
Uh-huh.
but you have one negative. So opposite would be negative 4.
Mm-hmm.
And you have another negative. So opposite of that would be back to 4.
Back to positive
You're
4.
flip
Yeah.
flopping.
Yeah, I mean you're doing the opposite. And you've got sort of 2 opposites there. Negative 36 divided by negative 9. You can think about 36 divided by 9. And then you've got opposite that's negative 4, opposite that's, like you said, positive 4. So we have those same 2 strategies that we've been playing with in multiplication seem to be appearing in division. Hey, that kind of makes sense because they're inverse operations of each other. All right, so we have those 2 ideas happening. Now I give you negative 36 divided by 9.
So I would think about 36 divided by 9 is 4.
Mm-hmm.
And the opposite of that would be negative 4.
Cool. Can you think about it the other way? Like this idea of jumps. How many nines are in negative 36?
I mean,
That's kind of
there's
weird.
4, but opposite of it. It's they're not. There's 4 nines and 36.
Yeah. You know
But
how in multiplication we can say I've got this many groups and I've got this many in the group? So division can kind of turn around the same way, where we've been asking how many of the divisor are in the dividend. But could we also say, so this negative 36 divided by 9, could we say I've got 9 groups? And I want to know, wait, is it groups?
Nine somethings.
9 somethings, and I want to know, I'm basically trying to turn it into a missing factor problem.
Yeah. So
9 times
somethings.
what? Yeah. 9 times what? Nine, what are the things? 9 what's is negative 36.
Yeah.
That could be another way of thinking about that.
Yeah.
So then I've got a number line where I'm thinking not about jumps of 9. Now I'm thinking about
9 jumps.
9 jumps. Thank you. And what would those have to be? Oh, that would have to be 4. And in this case, since I'm landing on negative 36, they'd have to be negative jumps of negative 4.
And this would come after work you've done as early as 3rd grade with partitive and quotative division.
Yes.
Where they say 4 groups of 9, 9 groups of 4, they're equivalent. Yeah. Yeah.
So one thing I've got on my paper that you might not realize is that I've got 9 times blank equals negative 36. Kind of underneath and shifted a little bit from the negative 36 divided by 9 equals blank. I've turned that into a missing factor problem.
Sure.
So we can kind of think about those jumps that we were thinking about before.
Okay.
Cool. All right, next problem. How about if I were to ask you for 36 divided by negative 9 in 2 ways? You want to do your favorite way first, or do you
want to... Yeah. The easiest way for me to think about it is 36 divided by 9 is 4. And the opposite of that,
because we got 1 negative, so the opposite is negative 4. Okay, it totally makes sense. I might write that. No, I'm not going to do that yet. Never mind. Keep going.
And then
can you think of the can you make it a missing factor problem?
How many negative 9s? Oh, that's trickier for me. How many negative 9s are in 36? Nope.
Yeah, that's weird, right?
That's harder when it's not negative 36 divided by 9.
Okay. Can you think of it as negative 9 times that something, the thing we don't know, equals 36?
So negative 9 times negative 4 is 36.
So now we're really back to what we were thinking about in multiplication. So we needed to have done a good job in multiplication to now be sort of able to make sense of that missing add-in problem, or missing factor problem.
That might be the toughest one we've done. Yeah.
I think, the missing factor problem. So eventually, I think we
specifically when
positive divided by negative.
Yeah.
Okay.
Because it's hard to picture how many are in that. How many quotatively? How many negative 9s are in 36? That's tricky to do. But also because you have negative groups of things. Yeah, I think that's the trickiest one. And I think it's fair for teachers to know that some of them are easier for kids to mess with than others.
For kids to conceptualize.
All problems not created equal.
Yeah. So once we've sort of yes, because if we just give kids rules, then it looks like they're all the same. But if kids are actually trying to think about them, that can be a place that stymies them. We don't want to stymie kids. Let's recognize where kids might get stymied, kind of help them think through it. And also, since we're developing both strategies, then help kind of nudge kids towards, can I think about this problem as kind of an opposite problem? So if 36 divided by 9 is 4, and I've got that 1 negative in there, then I'm going to think about it as the opposite of 4 or negative 4.
Yeah.
Cool. Okay, so then I'm going to do the same kind of thing with a different set of numbers. So I might say 24 divided by 8, negative 4 divided by negative 8, negative 24 divided by 8, and 24 divided by negative 8. So I'm going to model these. We're going to get thoughts on the board, and we're going to bring out both strategies. Okay.
And when you wrap up this string, this is your first, maybe the first division string. What is your summary Oh, that's interesting that you're hoping kids say that you kind of wrap up with. I think that's hard for teachers sometimes to come up with what's the like
That's hard for me.
the
Some,
wrap.
yeah,
Yeah.
yeah, absolutely. I
So it's
appreciate
the
you asking
first
about it.
it's the first string. So we're not anchoring the learning, we're moving on. It's the very first.
We'd like to give kids multiple experiences. Yep.
Sure.
So I think I would be wanting to pull back to everything that we've been learning about multiplication.
Mhm.
And I would want to say something like, hey, it seems really helpful that we can reason about how many of these are in those. That's the quotative meaning of division.
Uh-huh.
But sometimes that gets funky. And so it could be helpful to think about a missing factor problem.
Mhm.
But sometimes even that's kind of weird. And so, wow, this idea of thinking about negatives and reflections seems to really be helpful, that we
Yep.
kind of pull that negative one out and kind of think about the problem and then take the opposite for every negative that's in there, for every,
Yeah.
every reflection that's going to happen. Yep.
And I think that idea of thinking about the fact and then opposite is something that is kind of tried and true, and it's might be what people end up doing lots of the time. But I think that the disconnect is that sometimes we launch in to say, hey guys, just think about it this way. And we don't give kids the time or experience to develop that understanding themselves. They don't generalize for themselves. I can just think about the fact and opposite.
So it becomes one more rule to memorize and mix up.
Right.
Yeah.
Right.
Yeah.
Right.
Yeah. And if kids are really trying to make sense of it with a quotative meaning,
Hmm.
and you're just telling them to memorize some opposite, or well, not even opposite, but just, like negative, negative is positive.
Hmm.
I think this is one of the traps of the algorithms is they think to themselves, oh, it doesn't make sense to me. Therefore, I'm not a math person. Bummer. And then either they try to memorize your thing and they know they're not going to do it well because they don't memorize well, or
Hmm.
they just keep trying to make sense of it, and then that bogs them down, and their identity as a math person takes a hit. So one of the
Hmm.
three main traps of algorithms, I think, is the fact that it can trap kids into thinking they're not a math person, when in reality they're trying to make sense of it more than maybe we might have, as we're just handing kids
Sure.
a bunch of rules. Yeah.
Yep. Yep.
We would be remiss if we did not also talk about the partitive meaning of division. And this is so important. And we need both. So I want to do the work that we just talked about, but I also want to do work with the partitive meaning of division. So if quotative is all about how many of the divisors are in the dividend, 36 divided by 9, how many nines are in 36, partitive division is a much more, it's funny because it's harder to do when we get out of whole numbers, but it's much more of a dealing out approach. It's kind of a sharing approach. We know the number of groups, but we don't know the share. We're trying to find the share. Is that right? Did I get that right? We know the number of groups. Sometimes I don't say that right when
We
I'm,
don't know how much is in each group.
yeah, we're trying to
Yeah.
find that share. Okay, cool. So ideally, we would have done work with partitive division with whole numbers so that students would see things like our 36 divided by 9. So that first
Hmm.
problem that we did in the string before, let's just think about it again. But this time when I write 36 divided by 9, I'm going to write 36 division symbol 9. So that's the line with the two dots. And then I'm going to write equals 36 ratio 9 over 9. I hate the word over because it's positional, but since we're audio here only and you can't see what I'm writing the fraction 36 ninths,
Hmm.
but it's really the ratio 36 to 9. And so I'm thinking about this division problem kind of as a ratio or a fraction. So I've got really 36 ninths on the board now. And kids might go, oh, well, I can simplify that fraction. And I might go, okay. And that's exactly the kind of thinking that we want to connect. We want, again, ideally, you would have done some work so that kids are already connecting division with ratios. And the equivalent ratio strategy in whole numbers, we could put a note to that in the show notes. We've done equivalent ratio division strategies with whole numbers.
Hmm.
I want to be able to be thinking about that here. So I'm thinking about like 36 ninths, and then I can simplify that. That's not crazy. We're just going to say that's 4. Cool. Then I'm going to say, so then what's negative 36 divided by negative 9? And I'm again going to write that as a ratio. So now I've got negative 36 over negative 9. I'm only saying over here because we're audio and you can't see what I'm writing. It's the ratio. And then I'm going to say, guys, what do we do when we simplify a fraction like that? Well, now I've clearly got 36 divided by 9 with these two negative ones. We could factor out those negative ones. So it's almost like I've got negative 1 divided by negative 1 times 36 divided by 9. And there's our opposites that we've been talking about before. 36 divided by 9 we know is 4. I can do it I think about it a couple of different ways. Once I get 36 divided by 9 is 4, then I can take the one negative 1, and the opposite of 4 is negative 4. And the other negative 1, the opposite of that negative 4, is back to 4. But I can also just look at that negative 1 divided by negative 1. Bam! Anything divided by itself is 1. And so I've just got 1 times 36 divided by 9, or 1 times 4 is 4. A couple different ways to think about that. I didn't really ask you how you thought about that. I kind of talked through that. Sorry.
No, it's fine. Totally fine.
Let me do the string where I just tell you what I'm thinking.
No, it's fine.
Okay, so next problem. What if I were to ask you negative 36 divided by 9, but I'm going to write it as negative 36 ninths? What are you thinking about?
I'm going to factor out the negative 1 and write 36 divided by 9 is 4.
Yep.
And then I'm going to multiply that by negative 1, which is negative 4.
And multiplying by negative 1 is, we could also say, is the opposite. And the opposite of 4 is negative 4. I just want to keep bringing that language in with kids. Cool. And y'all, I can keep going with that exact same string that we just did. So now I would have the next problem, which was a negative 36. Where am I? No, 36 divided by negative 9. But I'm going to write it like a ratio. So 36 over negative 9. And I'm going to have kids think about that one. And then I'm going to give the next set of numbers, 24 divided by 8, negative 24. Well, so let me say it this way. 24 eighths, negative 24. No, I don't know how to say it that way. Negative 24 divided by negative 8 as a ratio. So negative 24 over negative 8. And every time we're asking kids, like, can we factor out these negative ones? And what does it mean? How many opposites are we doing here? I'm going to keep bringing in the word opposite. We've got negative ones divided by each other, or just one negative one. It's just one opposite, and all of that is coming together to just connect with all the work that we've done with integer multiplication.
Right.
And it all just works.
So, yeah. So teachers do a good job with multiplication and then with division, both meanings and the definition of integers being opposite.
And dun to dun, you've got kids actually understanding integers, and then you can move on and use that those integer operations in solving problems. Y'all, thanks for tuning in. Thanks for tuning in when it's a little bit higher math. I hope you guys enjoy the higher math when we try to talk it out verbally, but we sure appreciate you trying to improve your mathematics and for trying to teach more and more real math. To find out more about the Math is Figureoutable movement, visit mathisfigureoutable.com. Let's keep spreading the word that math is figureoutable. Did you hear the announcement? Workshop registration is open.
It's in these workshops where you will learn all the things that you need to make math more figureoutable. Select your workshop at mathisfigureoutable.com/action.
Hey, kindergarten through 12th grade educators, we have a workshop for you. Build your numeracy, learn the teacher moves, equip yourself with the knowledge you need to have students naturally engaged in their learning. No matter what grade level you teach, we have a targeted workshop for you.
Find your best workshop for you at mathisfigureoutable.com/action.
Let's change the world together and make math more figureoutable.